Hello, I'm Prateek and welcome to this video where we will be using IMDB movie dataset to create a movie recommendation system using TF-IDF vectorizer and latest semantic analysis machine learning model for dimensionality reduction. So in the past few videos that I have built on recommendation system, I just used cosine similarity and TF-IDF vectorizer to create the similarity data frame. But this time I'm going to use the latent semantic analysis model, which will help us in the dimensionality reduction. So what I'm going to use here is the IMDB movie dataset. Now how I got this data is basically I had to fetch a lot of data, different dataset from IMDB website. These were the 6 different datasets that I fetched, and then did some data pre-processing task on that to finally get this data frame. And this is the data frame that I have exported and will be using in my current file to build the recommendation system. So I have created a video of all this data pre-processing task as well, and I will put that video in the description if you don't know where it is. So I will just start with importing all the required packages here, and once we have all the packages with us, the next thing we would just read this data frame into. So you can see the RAM consumption over here. Last few videos that I made where I was using the similarity data frame, the RAM consumption was really high. And I was basically using TPU where I was getting 35 GB of RAM. Right now I'm just using 12.7 GB of RAM because this task is not going to consume a lot of RAM, and that is mostly because of the dimensionality reduction that we are going to do. So rather than using over 1000 dimensions, we would just be using 100 dimensions. I'll show that in the next. So now we have imported the data frame, and this is what our data frame looks like. So we have index, okay, and then we have the T constant, which is unique identifier for the movie. We have the title type. We know that we are only using movie, and we have a total of 131,000 movies. The year, what is the runtime, genre, director, writers, average rating, number of votes, actors, and movie. And movie, this movie column is basically a combination of the title and the year, so that if there are any duplicates, we don't get confused with that. Then now what I'm going to do is I'm going to create a new column called content, which is going to just add all these data together, and that is so that we can use all this information to identify the features of a movie and then find similar movies. So that is created. Now the next step is so once we have all our data, the first thing we do is basically creating the bag of words, and then once we have the bag of words, then we create the TF-IDF from that. And once we have the TF-IDF, then we will go for the dimensionality reduction. So basically I'm using LSA model here. As I already mentioned, the role of LSA model is in this context is primarily to reduce the dimensionality of the data while retaining the important information. This is because high dimensional data can be difficult to work with, as we saw in the last few videos, and it can lead to overfitting in machine learning models as well. So the next step is basically applying the LSA model, not LSI. We are not using LSI here, we are using LSA. There is very minute difference between the LSA and LSI model. As LSI model mostly uses the probability approach for the dimensionality reduction, and this might consume a little bit of RAM and might take a little bit of time, but once that is done, we are all ready to take the input from the user for the movie and then recommend the most similar movies. Actually, I should have just calculated the time it is taking here. That would have been really helpful. And if you want to do that when you are coding, then what you can do is just add this piece of code in your cell, modulo time, and this will give you the time consumed by the system to actually run this particular cell. So as you can see here, n components means the number of features I want. So rather than having over 1,000 dimensions, how many dimensions do I want? And I have decided 100 here. It's up to you. You can play with this number, see if your model is improving or not improving when you change these numbers. And the algorithm I have used is ARPAC. And once this is done, I can just write the name of the movie. So again, I'm going to go with the Prestige because that is something we have been using in all our previous videos. And once the movie name is entered, it is just going to search for the most similar movies. And right now I'm printing 20 movies. You can reduce it or you can decrease it. So as you can see, The Dark Knight Rises, Interstellar, Memento, all these movies are very similar to what we have seen on IMDB website. So that would be all for this video. And as we can see, the dimensionality reduction using LSA model has helped us consume very less system power, and this is something you can easily deploy in the production as well. So yeah, I hope you like this video. If you guys have any questions, do let me know in the comments, and I'll be happy to answer. So I'll see you in the next video. Till then, happy learning.